All right, so I'm going to give a very brief introduction to what text mining is, especially in relation to STEM education research. All right, so I'm going to talk about four things today. First, what is text mining? Why is it important? Why we should care? What are some common techniques typically used in text mining? What are some of the technical and ethical considerations? Rob had already actually kind of hinted at some of those in the opening presentation, some of the ethical considerations and technical considerations when doing text mining. And then how is text mining used in STEM education research? So first, why text mining? What actually is text mining? Well, why should I care? First off, there's been an unprecedented increase in text-based data that's generated by educational processes and digital learning systems. You can probably think of some of these data sources actually right away that are probably generating this surplus of text data that has potential for providing insight into STEM learning context and for improving those contexts. Some of these data sources might include discussion forums, online assignments, instant messaging tools like the chat window we're using, social media, for example, which we're actually going to be digging into today. Let's see, and there's a number of different data sources as well. I've included a link at the bottom to a text that we use in some of my learning analytics courses at North Carolina State University. It's by Andrew Crum, Barbara Means, really excellent book called Learning Analytics Goes to School, a collaborative approach to improving education. Some of the potentials of these new sources of data include new features like just huge big data sets that allow for things like predictive modeling. This data is always on too, so new data is constantly being generated by these different systems. In some cases, this data is non-reactive as well. So what that means is it's being generated in authentic learning context as opposed to something in response to an intervention by a researcher. And then also one interesting thing that Josh is going to explore a little bit later in this workshop is how these, how even text-based data in many cases can be mined to tease out social relationships between people for social network analysis. So what is text mining exactly? I'm not going to give a formal definition of text mining today. I'm actually going to give a definition of text mining according to some of my graduate students. So according to some of them, text mining is a process for gaining insight into large amounts of text, a way to explore text in search of patterns. It's kind of like computer-assisted reading, and in some cases, it does feel quite magical. Text mining is not a substitute for traditional high-quality qualitative analysis. It's also, even though it's sometimes referred to as automated text analysis, it is not as automated as one would think. Someone has once described it to me as it's not too unlike reading tea leaves. And when we get to topic modeling in particular, that feels a lot like reading tea leaves. And some have said it's not magic. In fact, one of our guest speakers, Carolyn Penrose, had explicitly stated that text mining is not magic. It is not going to analyze qualitative data in the traditional way that you think it would. So I really love this kind of central focus question that Sylvia and Robinson point out in their Text Mining with R, Tidy Approach book. They sort of characterize text mining as answering one central question. So how do we quantify what a document is about? So what are common techniques actually used for quantifying text? So trying to quantify information about what a text is actually about. Well, there's basic text analysis. So I've linked to a really short but excellent article from the Digital Humanities called Word Counts is Amazing, that just kind of helps like explain that yes, word counts, as simple as they are, can actually generate some insight into certain contexts and can be very useful. Some other basic text analysis components include text pre-processing, which we'll do a little bit of today, not as extensively as we have done during the summer workshop. One of the downsides, of course, to text is very messy. Dealing with text is very messy, and it takes a lot of pre-processing necessary before you can actually get to that insight that we talked about. Doing basic word counts, so looking at popular words within certain contexts, which we'll do today with Twitter data, term frequencies, and a little bit more sophisticated approaches, term frequency, inverse document frequency, for looking at key words that are unique but important to certain documents. We will not do that today, but if you have ever done a Google search, you've experienced a little bit of TF-IDF, because supposedly that is part of their secret sauce for Google search results. Another common approach, I think Rob has used one of these lexicons pretty extensively, the linguistic inquiry word count lexicon, for not only sentiment analysis, but many other psychometric properties for measuring text. Dictionary-based methods, which is something we're going to do today, is another approach for quantifying what documents or text is about. And these make use of things called dictionaries or lexicons, which effectively assign a particular meaning or value or category to words within your data that you're analyzing. So for example, this was just randomly generated from some of the code that you saw earlier. These are words that are in the Bing sentiment lexicon, and these are words that have been associated with either positive or negative sentiments. And if you're interested in learning how some of these sentiment lexicons are developed and trained, there's a nice overview, again, I'll go backwards a little bit, in the Text Mining with R book, A Tidy Approach. Finally, the last thing that we kind of introduced in the Learning Analytics STEM Education Research Institute, the LASER Institute, is topic modeling. And we have not got to that yet in our institute, but we will be doing that as part of our workshops for the online community of practice this year. Again, there's a lot of formal definitions for topic modeling, but this is probably one of my favorites. So I'll actually go ahead and read it to you, and I've linked to the article there as well. These slides, again, I think some people had posted where these slides are. You can find these slides, again, in the main document that contains all of our resources. And if you click on the one that says presentation, it'll take you directly to the slideshow too, where you can access all the links. So with a bit of tongue-in-cheek, Meeks and Weingart describe topic modeling as leveraging occult statistical methods like Dirichlet priors and Bayesian models to provide, this is pretty accurate actually, to provide seductive but obscure results in the form of easily interpreted and manipulated topics. If you are interested in an overview of different topic modeling approaches, I really recommend this resource at the bottom, and they introduce specific topic modeling approaches for even short text, like Twitter posts, for example. If you ever look into topic modeling, you're eventually going to come across this figure here, which kind of gives an example of topic modeling in a nutshell. So for example, we can see that this particular document, after a latent Dirichlet allocation has been applied to this, has kind of sorted out 4 different topics. And these topics, you don't get with topic modeling something like a single word that explains what the whole topic is. What you get effectively is a list of words that are sort of associated with one another across various documents that make up a topic. And we can see in this document, one of the advantages of this approach is that topics can be assigned multiple topics to just a single document. So we can see in this document the keywords that make up specific topics, and we can see the proportion of this topic in this given document. So what are some technical and ethical considerations of text mining? I'm going to go through this really fast because I want to make sure we have plenty of time for a demo. I think we got about 25 minutes left. So despite the potential advantages of text-based data captured by educational technologies, there's a number of challenges. First of all, text data is typically unstructured, which means it's not in a nice rectangular format, so it's messy. And we need a lot of pre-processing to clean that up and get it ready for analysis. Digital trace data in general, but text mining, text data sometimes in particular, is often inaccessible. For example, it might be behind learning management systems that researchers do not have access to for a number of reasons. If you're working with digital trace data and text-based data on social media, for example, and if you're a Twitter user, you probably know that this type of data is not representative. In fact, we'll see some of that today in some of the sentiment analysis in the difference in sentiment expressed towards these two different standards. And it's probably because there's different groups that use these particular hashtags and keywords for that topic. And it's often incomplete as well. So for example, if you're mining data from a learning management system, some teachers may use the discussion forums heavily, but other teachers may not use them at all. And then Rob had also already touched upon some of these issues, the ethical and legal considerations, bias, not only in terms of algorithms, but also, for example, in social media accounts like positivity bias. We don't always show our dirty laundry on spaces like Twitter and Facebook. Terms of use, in some cases, text mining is simply illegal. In the cases of web scraping, some web pages, it's against their terms of use to scrape data from their pages. In other cases, it's not. And then there's FERPA issues to consider too when you're text mining and pulling data. So how is text mining used in STEM education research? I would describe it, and actually there's a really nice literature review of how text mining has been used in education in general, but about 80% of these articles, text mining has been used in science and math research, in particular math education research. They sort of summarize and wrap up text mining as three main applications. Performance, so using text mining to get feedback on student performance and assess student performance. Using text mining to provide or receive feedback to improve performance and support student academic performance. Also for supporting engagement, and also for a number of other uses as well.